Hello and welcome back. I have my Raspberry Pi right here. I put this heatsink on here that I got from AliExpress. Originally I had these three heatsinks on the bottom, as well as this heatsink on the CPU. Obviously you can imagine the thing ran great thermally. I think it was somewhere between 34 and 36, so it never even broke 100 degrees Fahrenheit. I wanted to do something a little more specialized. I also wanted to put headers on here. I also eventually want to put a hat on, or I have this coming, but it bolts onto the bottom. So if I want to put a hat on it, the heatsink isn't actually going to work very well. Also, the heatsink was getting in the way of where the header is supposed to go. So I ordered this to augment the thermals as well as give me some room to add and expand. I've been running this for a couple hours now. I didn't use the pads that came with it. It came with this heatsink, because they didn't appear to be thick enough. So what I did was I used the old thermal pad that came with, I didn't come with it, I bought it separately for this heatsink. This is like a Panasonic or Samsung thermal pad. It's like 13 watts per meter Kelvin. It's an extremely efficient thermal pad. I'm assuming these are probably not. They're obviously probably going to be the cheapest ones they can find. Might be half or 1 watt per meter Kelvin, so it's not going to dissipate a lot of heat. Again, though, it's a Raspberry Pi. It doesn't need a lot of heat dissipation. The one thing I did notice, though, is it looks like the pad is just a little bit too thick, and it looks like it's bowing out the board and the heatsink. So what I'm going to do is I'm just going to take off the heatsink here, and then I'm going to replace the thermal pad. Just because, again, don't really need to on this. I mean, it'd probably be fine just as is, but just for funds, see what happens. Interestingly enough, I was kind of worried about this being anodized. It's black anodized. The bottom is extremely flat, though. Let's see here. Amen. So let's take this off here. You can actually see. Maybe you can on the camera. You can see the indentation around the thermal pad. So you can see it was making really good contact. Again, it was probably a little extra pressure, maybe a little too much pressure. I want to see, I think the pink one's going to be just about perfect. The pink one might have been what was designed for the Pi 1. This is for Pi 1 and Pi 2. So my guess is the 2 were for the Pi 2 because I think it has that other chip over here. So what we're going to do, we'll just throw this on here. Stick it on there really good. It's funny though because it doesn't feel like it's making contact. You know, you can, but we'll see what happens. Maybe it is. Maybe it is, maybe it isn't. And again, it's a Raspberry Pi. It's not going to get super hot. So with the original good thermal pad, it was getting pretty hot. It was only getting up to like 120 though under load. So it was about 100 before I put this on. And then so it was about 117 is what I actually recorded. So it wasn't bad. Obviously well within the limits. It also dissipated extremely quick too. I did notice when I was running some of the tests, you could actually feel it getting hot on the outside edges here. So it was actually transferring the heat in, and then it was actually transferring the heat out. So it was actually working extremely well. Let's see here. All right, so change out the thermal pad. We'll go plug it back in, and we'll see what kind of temperatures we get. All right, thanks for watching.